Hi, let's solve today's daily challenge, that is remove zero sum consecutive nodes from linked list. So first let's understand what the question is. So in this question, you're given the head of a linked list and you need to repeatedly delete consecutive sequences of nodes that sum to zero until there are no such sequences. Alright, so let us understand using the example. So this is the first example given to us. Now this is the head node. Alright. Okay, now what we are being given is this head, and we have to remove all the sequences which sum up to 0. Okay, so here inside of this linked list, I can see that this part, right, if I sum it up, what value am I going to get? 0, right? 1 plus 2, which is 3, plus minus 3, which is 0. So I have to remove this part and return the rest of the linked list. Apart from this, there is no other part. See, after you have removed this, you cannot consider this as a sequence, right? Because this part is already removed. You'll be left with 3, 1. And inside of 3, 1, you have to find this sequence. So if it is not present, let's simply return the linked list. So that is what's happening here. So you have to simply return this linked list which is remaining, which is 3 and 1 and this. So this should be your answer. Okay, let us look at another example, right? So here again, this is my head node, and here if I go and see which nodes or sequence of node is giving me zero sum, so I can clearly see it's that this part, right? 3 and minus 3, which is going to give me zero sum. So I have to remove this part and I have to return the rest of the linked list. So rest of the linked list is what? 1, 2, 4 and null, right? So this is what I have to do. All right, so I hope you understood what the question is. Now how to solve this question, right? So first thing is, you can definitely solve it using the big O of n square approach. So in this approach, what you're going to do is you're going to iterate in the linked list twice, right? And for each and every node, you're going to iterate in the linked list and keep checking for these sequences and remove if there are any such sequences, right? And after that, you will definitely get an answer. But can we reduce this time complexity, right? So yes, we can, and we can bring down it to big O of n. How is that, right? So let us look at the intuition for that. Okay, so the only thing that matters in this question for you is to know what prefix sum is. All right, so we are going to leverage the power of prefix sum. All right, so what is prefix sum? So let us say we are given an array, right? Let us say we are given an array. Let me take these values: 1, 2, 3, minus 3 and 4. We are given these values. So the prefix sum array looks something like this. So you keep adding the values, right? So each and every element of this prefix sum array denotes up to that index what is the sum in the array, right? So this is 0, 1, 2, 3, 4. These are the indexes that I've mentioned. Now up to 0th index, if I go inside the array, what is the sum? It's 1. Up to 1 index, what is the sum? 1 plus 2, 3. Up to 2 index, what is the sum? 1 plus 2 plus 3, which is 6. Now up to 3rd index, what is the sum? Right? 6 minus 3. So you will get 3 in this case, right? And then up to 4th index, what is the sum? It's going to be 7. So this is what the prefix sum array is. Now how are we going to leverage the use of this prefix sum? See, okay, so here you can notice one thing, that 3 and 3 have appeared twice, which basically means here, right, here, sorry, after this, right, I added something which made my sum become equal again, right? So I'm adding something to 3, right? I'm adding something to 3, something we can write, and its value is 3. So this something has to be 0, right? Which simply denotes that this particular part, right, this particular part that we have added is a zero sum sequence, right? Which you can see from here also. If you add 3 and minus 3, what you get? 0. So the sum here is 0. So that is why we are getting this sum, right? This particular sum. So we had to add something to it, right? So what is that? We added 0. So that means that I can use this prefix sum and keep tracking duplicate values, right? So if there are no duplicate values, well and good. But as soon as I get a value which has been already present, I can know that okay, there was a zero sum sequence that was being added, and that is why my prefix sum value is same, right? I got the same prefix sum value, right? So you can see from this example that you have 2, 3 minus 3. So after, up to 2 the sum was 3, correct? And here the sum became 6, and here the sum became 3. So basically from this 3 sum, right, from this 3 sum you have to skip these two nodes up to this node, and you have to make it point to the next node. So basically if somehow you can get this node, right, with this, with the same sum that you're getting here, right, you can skip this part of the sequence, right, or of the linked list. So I hope up till here everything is clear to you, right, why we are going to use prefix sum, and like what is the intuition behind using prefix sum, right? It's this only, that whenever you have a sum, if it gets repeated, then you know the sum has already been present and we had to add some value which is 0, right? So that particular sequence is giving us 0 value. All right, so as I said, we will have to keep tracking these values, right? That at what node what was the sum, basically, kind of like that. So instead of an array we are going to use a map, right? So inside of our map, what are we going to store? First of all, this prefix sum value, right? We need the prefix sum, and along with it, for that sum, what was the node, right? So like 3 sum I got at this node, right? Let me show you here. Okay, so all right, let me remove this part. Let me draw this again. So you have this node 1, 2, 3, minus 3, and 4. So what you're going to do is you're going to make a map. Now, let's say its address is A, B, C, D, E. So inside of your map, you're going to store the address of the node up to which you are getting that prefix sum. Okay, so here you're going to store the node. So this map you will create. All right, so let's start doing it, right? So initially it will be 0, right? Our answer will be 0. Okay, like our sum, prefix sum value will be 0. Now we'll start calculating. So here my sum will become 1. So at what node I am getting this prefix sum 1? So I am getting, so inside of my map, right? Map of 1 is going to be what? A. All right, keep moving. Add 2 to your sum, right? So this is your sum value. Now here your sum value will become 3. So add it to your map. So it will become B, right? Up to this prefix sum, the value is B. Okay, move ahead and add the next value, which is giving you S is equal to 6. So for this sum value 6, add that particular node up to which you are getting this value. Then D, right? So D node will give you a sum of 3. So add it in your map, right? So now, okay, wait, you will not add values, right, that are already existing. That means I have got a duplicate value. S is equal to 3. It's already present inside of my map. So you have to keep checking if this value is occurring inside of the map. If it is occurring, so you have to perform some deletion. If it is not, then you have to simply move ahead. So we will remove this. Now what I have to do, I have to take that node where the sum was 3 previously, right? Here is also 3, but we have to take that node where the sum was 3, so which was B, right? So this is the use of the map, right? That is why we are using map. So from MP of 3 I can directly get this B, right? So of B, right, I have to delete this particular sequence. So I have to make B's next pointer point to the next pointer of your current node, right? So current node is D. So you have to basically make whatever pointer you are having here. So basically here you are making B of next equal to what? D of next. D was your current node, right? So this is how you have to like keep doing, keep adding these values and keep checking if this value exists, then you have to perform this deletion. All right, let us do a dry run quickly on another example, right? So here is the third example. Okay. Okay, before I explain you the third example, I have to also explain you that, see, if we see the first example, right? So we can see that there is a possibility where your head node will also be deleted. Your head will become a new node, right? So for that, we can simply fix it using a dummy node. So I will take a dummy. And also here you can see that if you will, try to add values inside the map, here it will be 1, here it will be 3, here it will become 0. So from where are you going to get 0? See, whenever your head has to be deleted, right, you will definitely get a some value 0, right? From your head, if there is a sequence which has to be deleted, then you will definitely get a some value 0. So you have to also hash it in your map, and at this particular 0 you have to place this dummy node, right? So this way you will be able to handle this condition also, right? And in the last, you know that you can always return dummy of next, right? And this basically makes the job easier, right? We are able to handle these edge cases efficiently. All right, so we are going to take dummy node, and then we are going to create the map. And please do not forget this, because in case there is a head, right, there is a sequence in which the sequence starts with the head node, right? There you are going to get zero sum, right? And that should be present inside of your map. But if you keep doing it like this, it will not be, right? So include these two, right? So declare a dummy node and also declare mp of 0 as dummy. All right, now let us go ahead and see the third test case. Okay, so this is the case. Now let me start doing a dry run. So as I said, first take a dummy node, make it point to your head, right? This is your head. Now after you are done with that, also hash your map of 0 value as this dummy node, right? So let me say this is dummy. Okay, so your map of 0 is going to take dummy. All right, now start iterating inside of the linked list. So sum initially will be 0. Here your sum will become what? 1. So hash it in your map, right? So map of 1, right? The sum will be A. Then do it for B. So 1 plus 3 is 4. So this value is not, you have to only add if the value is not existing, correct? So MP of 4 will become B. Then come here. Your sum is now 6. So it's not present. So hash it. So what will you do? C you will add, right? Here 6 minus 3 you will do. So sum will become here 3. So this is also not present. So put it inside of your map and put the node. Now add E. Now see, here your sum is becoming 1 and 1 is already present here inside of your map. So what you have to do now, you have to, you know that this is that sequence, right? Which is of 0 sum, and you have to remove it, right? So what you will do, you will remove this particular part. So how will you remove this particular part? Get the node from here, map of this prefix sum value that you're getting again. Get this value and make its next point to F. All right. Okay, now let us continue our iterations. So you have some value as 1 here, so some value will become 6 here. Okay, now the 6 is already existing here, right? But don't you think it will give you wrong answer? Because see, you don't have to delete this, right? Because you are considering this not part of your linked list, so you have to remove all these values from your map also. So what you have to do is, as soon as you get this node, right, so you have to start from this node and again calculate the prefix sum, right? With 1, calculate the prefix sum with up to B, C, D and E, and remove these sums from the map. So you have to use mp dot erase and remove this from your map. And this is because you can see that the sums can repeat, but this should actually be should be put inside of your map, correct? But because of this s is equal to 6, which is a part of your deleted sequence, you are checking this and you will again, try to delete up to this part, right? So which will give you wrong answer, isn't it? So you have to keep in mind this also, that you have to erase the values of the deleted sums from the map. All right, now, okay, so s is equal to 6. So basically if I have to delete all these, so I will be removing all these values from the map. So I'll be left with this. Now if I'm left with this, then I have to hash this 6 value, and it will be what? Now it will be f, correct? Then move ahead, add next value, s is equal to 11. So now map of 11 is going to contain g. All right, now here is, okay, it became equal to 6 because 11 minus 5 is 6. It's already present inside of the map. So, you have to delete this sequence. So what is the sequence that you have to delete? So you have to get MP of 6, which is F, right? So after F, all these values, right? Up to this is your current node, correct? So you have to delete these values. So as soon as you delete these values, you have to make its pointer point to this particular node, correct? So now you can see, yeah, all right. Now let us keep moving ahead. Also, as I said, you have to remove these values from your map, right? So it is repeating, but you have to remove this 11 from your map. So you will remove this 11 from your map and keep doing the iterations. Then you will be having map of 6 plus 1, that is 7, is equal to I, and then you will reach null. So basically you have completed the iteration, and here you have to simply return, see, the remaining linked list is now this, right? You can also see your pointers pointing like this, right? Because we are doing that. Now after this, you will be having your dummy node here, correct? Your dummy is present here. So you will simply return dummy of next. So I hope the approach is completely clear, right? Okay, so now let us look at the time complexity before we see the code, right? Quickly. So time complexity, you can already see here is, we are only iterating the linked list once, right? So it will be big O of n. There is only one iteration. Sorry, there is only one pass of the whole linked list. Then your space complexity is going to be because of the map, and in the worst case, it can be up to big O of n, right? So I hope this time complexity and space complexity are also clear to you. Now let us go ahead and quickly see the code, right? Okay. See, so the first thing I did is declare the dummy node. After declaring the dummy node, I am getting the dummy next as head, right? So I'm attaching this dummy to your linked list and before head. After that, I am taking this sum, right? So this sum denotes the variable in which we will be calculating the prefix sum, right? Then we are declaring the map. Inside of this map, as I showed you, what we are storing. We are storing the prefix sum value, and we are storing the node up to which that's this particular int value was your prefix sum, right? Then uh, I already told you that in cases where you have to delete right from the head node, right? If the sequence includes the head node also, then for that sequence, you're going to get zero sum, right? So you have to hash it also and make it equal to dummy so that the deletion will be much easier. All right, now start iterating, and I'm taking the head, and up to head is does not become null, right? We are iterating. Calculate the sum. Now do the main thing here, right? Check if this sum already exists inside the map, right? If it doesn't, you have to simply add it. But if it exists, what you have to do? You have to perform deletion, correct? So you could have done this, right? You could have directly made, like, get this particular node from the map and directly make its next point to your current nodes next. But as we saw that we have to delete these prefix sum values, right? Because they can appear again, right? But that will give you the wrong answer, right? So you have to remove these values from the map, right? So for that reason, we'll have to iterate in this particular sequence again. All right, so basically you will take this node, right? So MP of sum basically denotes the node where that prefix sum was already existing, right? And we are also taking the start node, right? So basically start is the start of this sequence, right? And node simply is going to iterate in this sequence. Okay, so start your traversal and make it equal to next, and keep calculating the prefix sum. So here what we are doing is we are taking, okay, up to here the sum was what? 1. So keep adding this node, so sum becomes 4. Erase it from the map, right? Erase it from the map. Then okay, 4 plus 2, 6. Erase it from the map. Then 6 plus minus 3, 3. Erase it from the map. Then 3 plus minus 2, 1, right? So 1, obviously we don't have to go up to 1, right? So that is why we have added this condition. Please don't remove this particular 1 value from your the map, right? Okay, so This is what you're doing. So you're doing up till you do not reach the head, only then you have to remove. Okay, after this you have to simply make your start of next point to your head of next. Okay, um okay, I have added it at the wrong place. You have to basically add it here after the while loop. All right, so after your while loop is done, you have to simply make your start of next point to head of next, because now you have removed the values from the map. And yeah, so we have basically done whatever we had to do. Correct. Now you can simply see that here we are iterating and simply return dummy of next. So this is how you had to like solve this question, and this is how you leverage the power of prefix sum.